as Kibo, the Japanese word for hope. The 35th flight of Discovery marks the 123rd Space Shuttle flight and the 26th shuttle mission to the space station. This will be the second of 3 missions that will complete the Japan Aerospace Exploration Agency's Kibo laboratory. Discovery's commander is Mark Kelly, a native of West Orange, New Jersey, who's making his 3rd flight aboard the shuttle. Kelly is one of only 2 members of the crew that have previously flown in space. He flew as the pilot of STS-108 in 2001, and again as the pilot of STS-124 in 2006. This will be his first flight as commander. Navy Commander Ken Ham will make his first voyage into space as the pilot of Discovery. Ham is a highly experienced pilot with more than 3,700 hours in 40 different aircraft. He will assist with rendezvous and docking activities, and will also fly the shuttle after it undocks and flies a 360-degree loop around the station near the end of the mission. Mission Specialist Karen Nyberg will also be making her first flight into space. Nyberg will serve as Mission Specialist 1 and will operate 3 different robotic arms: the Remote Manipulator System, the Space Station Robotic Arm, and the new Japanese robotic arm located at the forward end cone of Kibo. Air Force Colonel Ron Guerin will make his first flight into space aboard Discovery as Mission Specialist 2 and will make 3 spacewalks during the mission. Guerin will also back up Ham during rendezvous and docking, and will serve as Discovery's flight engineer, working with Kelly and Ham during launch and landing on the shuttle's flight deck. Discovery's Mission Specialist 3, Mike Fossum, is the second veteran space flyer on the crew. He completed his first flight on STS-124 in 2006, logging over 300 hours on orbit, including 21 hours of spacewalks. Fossum will be the lead for all 3 of the mission's planned spacewalks. The crew of Discovery includes Japanese astronaut Akihiko Hoshide, one of the first Japanese astronauts selected to train for flight aboard the International Space Station. Hoshide will install the Japanese pressurized module using the Space Station robotic arm and will be the first to float inside the lab once it's opened. One of the major objectives of the mission will be the exchange of Expedition 17 crew members. Station Flight Engineer and Science Officer Greg Shamatoff will remain aboard the station when Discovery departs. Shamatoff will spend the next 6 months on orbit, returning to Earth aboard Endeavour during shuttle mission STS-126. Discovery will bring home Station Flight Engineer Garrett Reisman, who has lived on the station since STS-123 delivered the first component of Kibo in March. The STS-124 crew will see its timeline vary from that of recent shuttle flights. The use of a special sensor and laser system to conduct a detailed inspection of Discovery's heat shield will take place later than usual. Because the Kibo laboratory module is so large, there is not enough room in Discovery's payload bay to carry the 50-foot-long Orbiter Boom Sensor System robotic arm extension that is used to perform the detailed inspection of the shuttle. The crew of STS-123 left the boom extension on board the station in March, so the crew of Discovery could use it during this mission. Once Kibo is installed on the station, the boom will be returned to Discovery and used to inspect the heat shield later in the flight. Just before the shuttle docks with the station, Kelly will fly the shuttle to within about 600 feet of the station and perform a slow backflip called a rendezvous pitch maneuver. This space ballet is performed during every mission to allow station crew members to take detailed digital photographs of the underside of the shuttle for analysis by engineers on Earth. The highlight of the mission will be the delivery of the second piece of the Japan Aerospace Exploration Agency laboratory, Kibo. Kibo, also known as the Japanese pressurized module, is nearly 14.5 feet in diameter and over 37 feet long. The bus-sized module is the largest station component ever launched aboard the shuttle and will be the station's largest laboratory once it's attached.
It's its own little spacecraft in the sense that it has an environmental system, electrical system, its own computer system, its own robotic arm. It's going to be used for fundamental chemistry, fluid physics, regular physics, biology experiments. Some of those will come up at a later time, but it's going to be a world-class laboratory.
The Kibo Laboratory Complex will include 2 television cameras and 2 6-jointed robotic arms, the first of which will be delivered on STS-124. Next year, another shuttle crew will deliver the third and final component of Kibo, an exterior front porch to allow experiments to be exposed to space. Back on Earth, the installation of the large Kibo lab will enable the Japanese flight control team to begin work in earnest from its mission control center in Tsukuba, Japan. There are 3 spacewalks scheduled for the flight of STS-124. Each will last about 6.5 hours. On Flight Day 4, Fossum and Guerin will transfer the orbiter boom sensor system back to the shuttle from its temporary location on the station's truss, where it was stored during the last shuttle mission. The 2 spacewalkers also will conduct further inspection of a damaged solar array joint that enables the starboard solar arrays to rotate and follow the sun. Fossum and Guerin will demonstrate techniques that may be used to help clean contamination from the joint's rotating ring. The crew will then prepare the Kibo module for its removal from the shuttle payload bay. Later that day, Hoshide will install the module on the port or left side of the Harmony connecting module. On Flight Day 6, Fossum and Guerin will install covers and external television equipment on Kibo and remove covers from the module's new robotic arm. The first section of Kibo, the Japanese logistics module, was carried to orbit during STS-123 in March and installed in a temporary parking place on top of Harmony in preparation for delivery of the main Kibo lab during STS-124. On Flight Day 7, Nyberg and Hoshide will relocate the Japanese logistics module to its permanent position on Kibo, using the space station robotic arm. On Flight Day 9, Fossum and Guerin will participate in what is expected to be a truly spectacular spacewalk as they work to replace a depleted nitrogen tank on the station's starboard truss used to pressurize station cooling systems. Guerin will grasp the 550-pound tank while attached to the end of the space station robotic arm. Then, Nyberg will maneuver the arm in a windshield wiper move, carrying Guerin and the tank on a panoramic trip as far as the station arm can reach to a stowage platform on the other end of the outpost, called ESP-3.
So this maneuver right here takes about 20 minutes, and on the top here I'll be almost 100 feet above the station, looking straight down on the aft side of the station and the Earth 250 miles below. So it'll be a pretty spectacular view and a pretty spectacular ride.
Guerin will then take a new nitrogen tank and reverse course, moving from the storage platform back to the starboard truss for its installation and activation.
We tend to get a lot of the accolades, but there are a lot of people that are behind the scenes that are certainly as critical as we are to the success of this mission.
There are people who train us, people who actually manufacture the module, the orbiter, doing work down at the Cape, all the flight controllers here at Johnson Space Center, as well as in Tsukuba Space Center, who's working really hard, long hours.
Everywhere you go, every center you go, if you go to the subcontractors, everybody from the people that are turning the bolts and the nuts and to the people who are designing things, you could see it in their eyes. You can see how excited they are to be a part of it, because really it's an amazing accomplishment what is being achieved on the ISS through this construction.